moving on towards the 2D part, we just make a rectangle here. Now, going to the dimension section, just I'm going to give the dimension. Now here we can see that the dimension part is not written. Here it is written h1. Okay. And if I'm going to give this, here it is written v2. So where the dimension part is written, it's written, you can see on the left hand side below the sketching toolbox, that is detail view. And here you can see dimensions 2, h1 and v2. So just change the parameter from here. Like if we am going to give h1 50 mm and then 10 mm, which means that in order to change the dimension, we have to change from the details view. Okay. In details view, whatever we have made in this sketch, all the thing is being given here. Like we have made here 4h, and all those 4h, every line has a specific and unique number, that is line 30, line 31, line 32 and line 33. Okay. So if you want, you can just select the dimension here and just delete it. Okay. Going to the general option, we just give the dimension, and if we want to change the dimension, we just write here 80 and then 20. Now moving on to the roller, if we move the roller to mouse roller to the upper direction, zoom in occurs, and if we move the roller to the lower direction, zoom out occurs. Means zoom in and zoom out is done by this ruler. And if we move the ruler, if we press the ruler and move the mouse, you can see that we can rotate our screen. Okay. So zoom in and zoom out is being done by moving the mouse ruler up and down. And if we press the ruler button inside, we can see that we can rotate the screen. And if we want to make screen in previous look, then look at function we can click on. Okay. Now if we want to move this screen, which is known as panning, then we just hold the control ctrl button from our screen on the keyboard and then press the roller. Means just hold the control key from the keyboard and just press the roller, so panning occurs. And if we just press the roller, then rotate occurs. So while holding the control key, panning occurs, and just without control key, rotating occurs. Moving the ruler up, zoom in, and moving the ruler down, zoom out. Just click on look at function again to return to the previous view. Okay. Now if somehow, unfortunately, if your mouse ruler is not working, then you can just do the same on these options. You may see here rotate, pan, zoom, box zoom, zoom to fit, and magnifier window, previous view, next view. Okay. So clicking on this rotate option, and then we have to click on left mouse button, not the roller button now. If we are clicking here, then click on the left mouse button and you can rotate the screen. If your roller is not working, then you can use this option also. ANSYS provide this feature also. Okay. Just click on the left mouse button on the panning option and you can pan the window. Just click on the left mouse button, the magnifier window on icon, and then click on left mouse button, and if you move the mouse upwards, then zooming occurs. And clicking all the left mouse button, if you move the or drag the mouse downward, then zoom out occurs. Okay. Then here also, if you want to zoom a particular region, like this edge we want to see clearly, then we can just make this, choose this option. Okay. It's a box zoom. Okay. And zoom to fit, if you want to fit our screen here, then zoom to fit option is used. Okay. Sometimes our figure gets lost, So on the click on zoom to fit, we can find some figure. Suppose we have made a figure and our figure gets lost. Okay, we are not able to find our figure, then we will click just on zoom to fit, and wherever the figure will be there, it will straight away come to our screen by this option, zoom to fit option. Okay, so this we can do manipulations of the screen by just clicking on this option, or you can use the mouse ruler also to. Okay, now after making a 2D figure, after we have made a 2D figure, we just move towards 3D, and it is modeling part. Okay, and the first 3D tool you are very familiar with, its name is extrude. In sketching, we will make a 2D figure, and then moving to the modeling, we are going to make a 3D figure from that 2D figure. Okay, so the first command or menu is extrude. We just click on this extrude option, and here we have to just apply on, select on that sketch on which we want to do the extrude. Now how to find that sketch? You just, since we have made a figure on XY plane, we just go to that, just click on that plus icon, and here we can see sketch 1. Just select that and click on apply button, and we can see here that the figure has been already extruded here, but it's showing us a wireframe view, not a 3D view. Okay, and we can see also a lightning type option here. This lightning type option means that we have not generated the figure. We have just selected the figure but not generated the icon or menu. So just right click on it and you can see here generate option. Its shortcut is F5. Just click on generate option and you can see here that the figure is now visible to us in 3D model. Okay. Now if you don't want to extrude this figure, just right click on it and here you can see a delete option. You can just delete this. The message comes, just click on yes option and you have just deleted the extrude option. So this tree helps in manipulating the 2D and 3D figure also. Suppose we have selected sketch 1 here, apply, and we want to just increase the length of the extruded portion. We can see here in detail view, here we can see FD1 depth. It's here 30 mm. So if we write here 80 mm and press enter, we can see that the extruded portion is being increased. Or we can write here 200 mm and same, press right click on this and click on generate option. You can also select this and here you can see generate option. You can just generate here also and you may see that this figure has been created. Now here in detail window we can see here 200 mm is already written. If we want to change, just write 300 here. But after making any change, the changes will apply only if you just generate this. See, where as soon as we have changed the parameter here, the tick marks get disappear and then that lightning signals appears. So just generate these options and you can see that the figure length has been increased. Okay, so the figure has been made in XY plane, and when it is going to be converted in 3D, we can see here that it is being moved in Z plane. Okay, now in extrude 2 portion, we can see here that sketch 1 is being seen. That is the only same sketch which we have made earlier with the dimension 80 by 20 mm. Okay, so till here you have understood.
Yes, sir. Yes. Yes.
Okay, now moving towards our part, if suppose we have made our figure, we are making a very small figure, but suppose we have completed our drawing. Okay, we just have to close this window. We just have to close the design modeler, and in project schematic window, we see here that after the geometry section, tick mark is been placed, which means that our geometry has been completed. So ANSYS is very systematic software, which means it provides you step by step that after which step you have to do what portion. Okay, like after engineering data, you have to make a geometry, and after geometry, you can see that you have to go to model section. So let's right click on it and click on edit option to open the model section. In model sections, we are going to give various parameters, whatever we are going to talking about in this ANSYS software. Like since it's static structure module, so or mechanical modules or mechanical parameters we are going to give in this, but all the parameters we are not going to give at all at once. We'll give here the parameters one by one. Okay, it takes some times in loading the page also, so just provide it full time so that your design has been fully loaded here. Okay, now you see that whatever you have made your model in this design modeler, it has been transferred to this mechanical systems. Okay, in the left hand side you can see outline window. You may also see the same options here in the menu bar: file, edit, view, units, tools, and help. And in the left hand side you may see here outline window. So this is the main window of our model section, where we can see project. Under project, that is model. Under model we can see here geometry, and geometry here is solid, which means it is selecting this solid option. And as I told you earlier that if you see here in this section details of solid, you may see here that in the material it is assigned structural steel, which means ANSYS by default works on structural steel materials. So how to change this material or how to assign new materials, I will let you know in next session. Okay, so by default I am just going to work on same structural steel materials. Now here you can see that on geometry portion a screen tick is being made, which means our geometry is being complete. Now below this there is a coordinate system option. Here also we have seen that green tick is being made, which means we don't have to do anything with the coordinate system. But in the meshing part, in the meshing section, we see that again that same lightning symbol is appears, which means we have to just generate the mesh. Now what is mesh? Can you let me know? Do you have any information or any knowledge about this word that is mesh?
I've known, sir, but I don't know it deeply.
Okay, have you studied any of the syllabus or topic like finite element analysis?
Yeah.
Yeah, you've studied it.
Yes, yes, yes.
Okay, so in this we see there that if we apply any of the pressure or force or any of the load on this face, we just what we do that we just take a small portion on this face, apply the same parameter of load, and this we take by the help of differentiation, and just whatever the result occurs, we just integrate this result so that the load whatever we are going to apply or whatever we have applied on it just equally and smoothly gets divided in every portion, each and every portion of this whole face, so that no face is being left. The load divides all over the face uniformly. So this is what we have studied in finite element analysis, FEA and FEM method. Now All this, we don't have to do any of the calculation in this. We just have to generate the mesh. Meshing is also one of the time taking topic. We just right click on it and we see here generate mesh. Just click on it and you can see here that our figure is evenly and equally divided into number of sections. This is also only known as mesh. Okay. Now, as soon as we generate the mesh, you can see that a green color tick mark is being just placed here, which means that we can move towards other option, that is static structure option. Okay. Now, in meshing, in details of meshing, there are various types of options. So I will let you know this later, that what is how to increase the sizing, how to increase the nodes and elements in the meshing. Okay, just for the time being, we just right click on it and click on generate mesh option. Now, below this, you can see an option that is static structural in the outline section, and here question mark is being placed. So you just right click on static structural option, go to insert option, and you may see various parameters here, which means whatever parameters we are going to apply on this figure, we have to apply from this. Just right click on it, click on insert option, and we can see here acceleration, standard or gravity, rotational velocity, pressure, hydrostatic pressure, force, remote force, bearing load, bolt pretension, moment. Okay. So upon from these, we are just going to apply a force on this face. So if we want to apply a force on this face, just select this force option. And you see here below this analysis setting, force option appears with a question mark sign, and this question mark says that we have not given parameters fully. Okay, which means that some parameters are missing here. And what are the parameters that are missing? We can see here in the details window, details of force window. First parameter is that on what portion of this geometry we have to apply this force. Now, if we want to apply this force on this whole face, we just select this face. If we want to apply this face, the force on this face, we have to just select this face. Okay. But if we want to apply the force on this edge, we have to change our selection, and we can change the selection from here. You may see here there are three selection options. Actually, there are four selection options, only three are opened here. First selection is vertex or node selection. Okay, vertex or node selection, which means if you want to select any node or any vertex of the figure, see here, a single node or single vertex is being just selected if we have just switch on this option. Okay, so if we want to select any node or any vertex, now why do we want to select any node or vertex? If we want to apply force or apply any of the parameter on the node, if we want to apply nodal node or any of the force or load on this vertex or node, we just switch on this selection and then select this. If we want to select the edge of any of the figure, we have to just click on this edge selection. Now, if we are placing the just cursor on that option, we can see here its name, vertex slash node, and then its shortcut key also CTRL plus P. And if we are moving the cursor to right, we can see here edge and control plus E. Like if we just press control plus E, edge selection is being on. Okay, and we can see here that we can just select the edges of our body. Okay, Beside that is the face selection, which means if we want to select the whole face, we just use this selection on. And beyond that, there is the body selection or element selection, means if we want to select the whole figure, then we just switch on this figure. Okay. Now, if we want to apply the force on this edge, just switch on the edge selection, select the edge on which you want to apply the force, and just click on apply option. So you may see here in this screen, design, force, time is 1 second, today's days, current time, and then force 0 Newton, and component is also 000, which means we have to give the magnitude also. In design window, whatever is the parameter that is being highlighted with yellow color, which means that we have to compulsory give the value. Without giving that, our analysis will not be done. Okay. So magnitude. Suppose we are taking the magnitude 100 Newton. Just writing here 100. Now we see here that now it's written here force 100 Newton. Okay.
Yeah.
But the direction is in this. Like if we are matching with this axis, the direction is in minus x direction, right? If we want this force to be applied in downward direction, how to change this? Below this, you are seeing here direction option. Below magnitude, we are seeing direction option. Now, if we change from here, see here the direction is already pointing here in the negative x direction. If we are changing here, the direction is only showing two modes, that is negative x and positive x. But we have to give the direction towards y axis downward. So what we have to do, just select any of the edge on the figure that is pointing towards the positive or negative y direction. As soon as we select, see the direction just changes to y axis, and we can change here from plus y or minus y. So if you want to give to this direction, just select this and click on apply. Now you may see here that our components is also being changed, and our force is already 100 Newton. Component showing 0, 100 and 0, which means in x, y and z. In x direction, there is no force applied. In y direction, 100 Newton force is being applied, and in z direction, no force is applied. Just we are seeing this in Cartesian form also. Okay. Now, analysis is just like a practical application also, which means that if we apply force without fixing any of the part, suppose we are this body is made in space, okay, and if we are applying force of any of the magnitudes, say 100 magnitude itself, then no result will occur in this. Okay, analysis will be done, but there will be no deflection, no stress, no strain, because we are not fixing a component. Just imagine that if we are moving any of the object in space, and if this object is moving continuously in downward direction without being stuck or being stopped by any of the obstacles, then there will be no change in the body, right? This only occurs in this case, which means we have to just make any of the part of this body fix. And how can we do this? Just right click on static structural option, click on insert, and we have to just add another parameter, that is fixed support. We see here fixed support. Just click on this option. Now, if we want to make this face, whole face fix, just click on this fix selection, select this face, and then apply on it. Okay, so you may see here that this whole face is being fixed here. Now, just remember one thing, just be careful here that on if we are fixing this face, then also nothing happens because we are applying force here and just fixing also here. So just click on this static structural option to see that whatever parameters we are applying on which body or which face we have applied the parameters. So in order to see the whole parameter, just click on it, static structure, and you can see here that A option is showing here red color and it's 100 Newton, which means that 100 Newton force is applied on this edge. And then B option is showing fixed support, which means that fixed support is being applied on this. Okay. Now, if you are understanding this, you have remembered the various types of beams here. Okay. And this is a simple cantilever case where one end is being fixed and on one end we have applied the force. Okay. In cantilever side, if you have remembered this, beams are of various type like cantilever, fixed, simply supported, continuous. So this is one of a type of a cantilever beam. Okay. Where one edge is being fixed and one is being on we have applied force. Okay. So till here, if you have any doubt, any question, just let me know. Anything which you have missed out or not understood, just let me know. Okay. You may see here above the outline option, we can see here there is also some option like inertial loads, which means we can give parameters from here also. Supports, either we right click and click on insert option and give the parameters here, or we can give the parameters from here. Okay. Now, after giving the parameter, just right click on static structure and we may see here one option that is solve option. Just click on it. Okay. The ANSYS will solve the result. Okay. It will take some time depending upon the parameters and figure size. Since it's a very small figure, so it have done the analysis within a minute. Now, our analysis has been performed. Now, in order to see the result based on these parameters, in order to see the result that what have been done, yeah, what is going to do done in this body, just click on this solution option. Right click on the solution option, click on insert, and you may see various result here, that is stress tool, deformation, strain, stress, energy, linearized stress. Now suppose we want to see deformation and we are taking here total deformation, just click on it. Okay. Whatever result we want to see, we just click on it and just add it one by one. Like in strain, we want to see one Messi's criteria or maximum principal strain, medieval principle, minimum principle, yeah, maximum shear strain. Just click on it. Again, click on solution. We want to see here stress. Stress also same types of criteria occurs like one Messi's maximum principle. Suppose we want to see a maximum shear stress, just click on it and just right click on the solution and click on evaluate all result. So after this, you may see here, just click on total deformation and you may see here that the result is being shown here. Now, if we read the result, first thing is that if we click on this static structure, we see here that we have made this end fixed. So in total deformation, here the deformation is minimum, or we say that the deformation is equal to 0. Seeing this color code, we see here that 0 minimum is written. So this deformation is here is 0. Going further, in this region, the deformation varies from 0 to 0.009218, and its unit is mm. Here you can see unit is written mm. Okay, so 0.009218 mm. Okay, now moving further, we can see here that is a deformation. Like as soon as we are moving towards the region where we have applied source force, the deformation is being increased. Okay, at the end we can see here that the maximum deformation is 0.082962 mm. So here it is total deformation is being seen. Now if you want to see maximum shear elastic strain, just double click on this result and you can see here that maximum shear elastic strain is 3.87 into e to the power minus 5, means 10 to the power minus 5. Okay, here it's maximum and minimum is at that point. So shear occurs where the support is being given, fixed support is being given, the shear start from there only, and where the force is being provided, the shear is minimum here, that is 1.64970 to the power minus 7. Now if you want to see maximum shear stress, just double click on this value and you can see the value. Okay, if you want to add more result, just right click on solution, click on insert, and just click on this. Suppose we want to see your strain energy, just right click on it. Again, click on solution, insert. If you want to see your one message, equivalent to one message, just click on it and just click on evaluate all result. You may see more result. Okay. So this is the main and end purpose of ANSYS software, that whatever figure you have made, the main advantage, the main application of ANSYS software is this only, that whatever figure, whatever designs you have made, we will provide various parameters, we will provide here materials, various parameters, and then on the basis of it, we can see whatever result we want to see here. Okay.